So very good. So speaking about just kind of moving the gear here a little bit, we mentioned the unsupervised and supervised learning a couple of times in our last 15, 20 minutes of talk. Guchon, I'm going to ask you as someone working in that space or who has also worked in the
hmm
supervised learning space before. What is the difference? Like if there was a layman sort of definition of these two terms, like the end-to-end algorithms, unsupervised, like can you give us a little bit of definitions from your perspective?
For sure, for sure. So, like, maybe just from the simple terms, right? Unsupervised learning, it's learning algorithms that basically doesn't require explicit data annotation. The reason that I'm saying explicit, I'm going to explain that later on. And this mainly goes back to most of the traditional ML clustering algorithms. Maybe we learned like k-means, BCA, like the hierarchical clustering, GMMs, and some new deep learning ones as well. So like maybe you heard like autoencoders, variational autoencoders, some parts of the diffusion networks as well. I think the main confusion comes from the indication of unsupervised versus self-supervised, because self-supervised is sometimes under the category of the unsupervised learning. One example is GPT. It's training significant data of the self-supervised. Sometimes, I mean, again, this is under the category of the unsupervised by predicting the next word, right? They are not giving any specific instructions or human in the loop, but the GPT is trying to predict the next word. And this is kind of self-supervised and unsupervised, right? And these are similar things are happening in the diffusion or variational encoder networks in the vision area. So you're giving the picture to the model, and model it's trying to blur the image and reconstruct the image back without giving any explicit data annotations. So what this helps networks, it's to generate the, going back to the previous discussion, the embeddings, like understanding of the, like the descriptors of the word, sentences, or also the image. So you will have large amount of the data going through these big models, and this is gonna learn to the essence of the data. And these are usually connected with some of the tasks where you have the supervised fine-tuning at the end. So I hope this explains the what it means on the supervised and supervised. Again, most of the times we see it.
Does a good job. Like if I had to abstract it out, it's basically unsupervised learning. You do not have any intervention or human in the loop. Data goes in, it sequentially goes through, your units of model, and then, you have an output, which in a lot of times gets the supervision towards the end of it. But there is some check and balance in the process, but not towards the beginning when it comes to bigger volume of data. Chenji and Guchan, maybe either one of you, is there any difference when it comes to deploying a supervised or unsupervised model on the platform? Does it make any change with respect to the size of the model, the latency of the system, or it doesn't matter? It's just the way we train one way or the other.
Yeah, I think it's maybe a little bit similar to synthetic and the human label pieces as well. This discussion, because you can deploy enormous amount of the data with unsupervised learning, and then your backbones or the main feature extractors can learn very diverse of the data. So that really bootstrap your capability of the model. So this piece is the main importance in the supervised learning to scalability, just having increase the capability of the model, because you have big models as well usually on those. Capability increase and the scalability increases. That's the main power of it.
Yeah, I want to add to Bhushan is that I don't think that in terms of deployment, there's not that much difference. Typically, what we use unsupervised or self-supervised is to train a good feature extractor at the back end. Which then the downstream part will be thrown away, and then you will be connected to another one that's trained and supervised, fine-tuned, not supervised data. And the typical different way to do that, depending on the task, you can do mask autoencoder type of unsupervised learning. If any nowadays, because the success of I think GPT type of model or BERT, those type of model, any task, if you can, it can be framed as a sequence learning problem. You can do the similar way, like mask out after tokens in the sequence and force the network to predict, learn. It applies to like machine learning based tracking, motion forecasting as well. So yeah, so that's what I would suggest. Another thing I want to point out, add to this is, because of the uniqueness of our application, right? It's like a self-driving car, and motion planning is a big part of it. I've seen people doing the purely reinforcement learning to train motion planner, which is, you can consider that as another way of doing unsupervised learning, which depends on like a reasonable simulation environment. Then you can just let the planner to train by itself. Don't collide with anything. Don't do curb strike. Don't do dangerous maneuvering. And then it can be trained in an unsupervised way.